We are all familiar with such splash screens or launching pages when we try to access the Wi-Fi at airport or hotels. Ubiquiti also supports such type of connection and call it Hotspot portal. This is my lab environment. If I go to UniFi network controller, go to settings for network, I already created a specific VLAN for guest network. You can see the guest network setting enabled, allow internet access enabled. Then I also created a corresponding Wi-Fi SSID for this guest network. One thing to notice is here for security protocol, you can see it's automatically changed to open because here I enabled hotspot portal. So this is the backend setting, everything is standard. Then in the lower part for this example Mac machine, let me go to Wi-Fi. Try to find the newly created Wi-Fi SSID, this one. Click on it. See, this pop-up is automatic. This is the so-called captive portal or hotspot portal. And there's a big button here. If I click login, I'm in. After 2 or 3 seconds, you see this strange string here. We will explain this later. Close it. So now I'm able to access internet. If I disconnect from Wi-Fi, then reconnect Wi-Fi, choose the lab 40. This time it doesn't pop up. I don't see the hotspot portal. During this process, a lot of interesting things happened. For example, why when I just connect to Wi-Fi, this blue pop-up automatically showed up? Why after clicking on the login button, I was redirected to this success blank page, and then all of a sudden I got access to internet? And then why if I disconnect and then reconnect Wi-Fi, I will not see the splash screen again. I will automatically get access to internet. In this video, we will explore them all. In the Wi-Fi SSID setting, because we enabled the hotspot portal for guest Wi-Fi, you will see this hotspot manager, and in this landing page setting, the show landing page is automatically enabled, and what you are seeing now, they are all default settings. By the way, in the later part of the video, we want to see the detailed network traffic, so let me disable the encrypted URL so that we will see what's the URL. But this setting by default is enabled. Let me save it. So this is the landing page or splash page you saw earlier in the video. In fact, just knowing the landing page setting in UniFi network controller is not enough for us to understand the process. For example, when the guest machine just connected to Wi-Fi, normally it's done, right? Why you see the landing page? It's the result of the cooperation between your guest machine's operating system and multiple UniFi devices. And then within your router, there's settings for redirector and for firewall rules. And because this is Wi-Fi, inside your access point, there are a lot of settings to enable the redirection. And then the landing page you just saw is running in the network controller. In my case, it's the cloud key. It is not running inside your router. In the video, we will talk about several important network ports, 80, 8880, and 8182. They have their own different usages and make the whole process more interesting. Let's start with the guest machine. Depending on the operating system, they use different so-called detection URLs to determine whether the internet is activated or not. So in this Wikipedia captive portal article, you will find this section called detection. It lists out 4 operating systems, macOS, Android, Windows, and Linux, how they use different URLs. In this video, I'm going to use macOS as an example. For all other operating systems, they work in almost the same way. The only difference is in the end, they use slightly different ways to determine whether internet is on or not. for example, Android expect a HTTP code 204, and for Windows, it expect to read this particular text, and for Linux, it expect this text. For macOS, for this video, as long as after visiting the test URL, it sees this string, the macOS is satisfied. It believes the internet is on. But you may ask, hold on a second, in our case, in the guest Wi-Fi network, you even don't have access to internet in the very beginning, right? Then how the guest machine can even get the result back? That's where the magic happens. This is my lab environment. I use UXG Pro as the router or gateway. There's only one AP. It's U6 Pro. In the lower part of the window, I have two sessions. I'm going to SSH into UXG Pro and the AP to see a setting for redirector. In the right part, let me SSH into the UXG Pro first. Let me try to find a process for redirector. Okay, found it. It's located in the user bin folder, and it's using this particular configuration file. If you directly run the command redirector, you can see it's by Ubiquiti, and it's for captive portal redirector. Let's see what's inside the configuration file. The redirector status is enabled. Why? Because we have a Wi-Fi guest network and the landing page is enabled. And the redirector URL is here. We will talk about this later, but I can already tell from the IP address is for my Cloud Key Plus. By the way, you can see the port number used is 8880. And then the HTTPS status is enabled. That's out of the scope for this video. And you can see this strange line. It's called redirect pattern. It's also pointing to the cloud key, but with a different port number. See, these two port numbers, they are different. We will talk about this difference later. This one, initial EC, means encryption. Remember I mentioned just for the convenience of seeing the details of the network traffics, I disabled the URL encryption in UniFi controller settings. In real world, you want to keep that enabled, but for this video, I have it disabled. That's why here you see this setting. Let's put this one aside for now. Go to the AP. You may think, okay, if we are talking about the redirector, you only run it in your router, right? No, because we are talking about Wi-Fi network, there's something as well in the AP. So in the left side, let me SSH into the U6 Pro. Similar way, let me see whether redirector is running and where is the configuration file. Yeah, it is running. The folder for the configuration file is slightly different than the router. Let me display the configuration file. Okay, we can see it's almost identical to the router's setting, but with one difference. See here, the redirect pattern. This time for the AP, it's this part, 8882. I know now you haven't seen the two parts working in action yet, so you may be already confused, but let me insert a background introduction about these two parts. This is a posting on the Ubiquiti forums. It's very old, more than 9 years ago, but because the reply was from UI team, I treat it as a authoritative information from Ubiquiti. It mentioned these two parts. So starting from a very old version of the network controller, the two parts were added. And they were added to fix redirector errors that occur to some guests. So Ubiquiti didn't explain what's the exact redirector errors and how the two parts work exactly, but it says 8881 is for wireless and 82 is for wired. Interestingly, based on what we just observed, it's the other way. So for the AP, which is for wireless, is 82, and for the router, which is wired, it has 81. Anyway, that web posting was 9 years ago. Maybe Ubiquiti changed the implementations, right? Let's move on. I know now you just saw the configuration for the redirector. You even don't know what's redirector for, right? Be patient. We will see it very soon. Now we are ready to see it in action from end to end. This is my lab environment. As I mentioned, I use UXG Pro as the gateway, a Cloud Key Plus running network controller, one switch, USW Pro 24, and I'm going to use a Mac Mini as the guest machine. I will run 2 Wiresharks. First, it's running on this Mac Mini. It will be listening to the Ethernet frames from guest machine perspective. The other one will be monitoring LAN communication for the gateway. And then we will understand how these devices, the guest machine, the AP, the hotspot portal, and the gateway, and the internet, how they work together to achieve this magical process. We are ready to capture frames using the 2 Wireshark sessions. In the left side, it's the Wireshark running within Mac machine. I'm going to capture the Wi-Fi interface. You may know in this way, I will only be able to capture the Ethernet frames instead of the wireless, the .11 frames, and that's exactly what I want. Because I don't care about the wireless information, I only want to see the Ethernet communications between the Mac machine and the AP. Okay, start capturing. You may see now the Wi-Fi is not connected, so you see nothing here. And then in the right side, see this Wireshark? It is connecting to this part, and this part is already set to mirror this part, and this part is connected to the gateway. So the right side Wireshark will capture the LAN frames from the gateway perspective. Okay, let me capture the Ethernet interface. Okay, started. In the left side, let me connect to Wi-Fi. Okay, it's connected to Lab 40, and we see the expected landing page, right? Then let me log in. Okay, it's connected, and then I see the success message. Close. We are done. Let me stop capturing. For easier understanding, I break down the whole process into multiple steps. So first step is about DNS, because for the Apple machine to even access the detection URL, it needs to know the IP address. In the left side, you can see the second frame. Apple machine ask the gateway query about the IP address for this captive.apple.com. Why this domain name? Remember in the Wikipedia article, this domain name is part of the hard-coded detection URL. So Mac Mini needs to know that, so that Mac Mini will see, okay, even though now I'm connected to Wi-Fi, do I have access to internet? It need to try this detection URL. And then see, this is the answer from 40.1, which is my gateway UXG Pro, right? It replies the IP address. If we go to the DNS response, expand answers, there are multiple answers, multiple corresponding IP addresses. The first one is ending with 203. In the diagram, you can see this is the DNS answer, and this is the one will be used by the Mac machine in the future. Someone may ask, hold on a second, now your computer even doesn't have access to internet. Why it can successfully resolve the domain name for the captive.apple.com, right? If you check the firewall rules from network controller under guest, you can see the DNS is allowed by default. That's why even though the machine cannot access other internet resources yet, it is able to resolve domain names. Okay, so it's super clear about the first step. Move on. In the second step, the Mac machine already knows the IP address for the detection URL's domain name. It will try to connect to this URL. So in the Wireshark session, let me change the display filter to HTTP. Okay, you can see the very first frame, it will get this URL. If you check the details for the HTTP section, you can see the complete URL. But if we check the reply, see the second frame is the direct reply to the first frame, right? It received a HTTP code 302. It says moved temporarily. If you check the details, somehow it's redirected to this IP address. This may be already familiar to you because we just saw it in the redirector setting. But let me put this aside, move on to the right side, because the left side of Wireshark is just between the guest machine and the AP, right? In this step, we are more interested whether the AP did anything. So let me do a filter because this is the LAN captured frames. So I need more filters just to show you the ones which we are interested, right? I filtered on the IP address for the AP and the guest machine, and let me filter the protocol to HTTP. You can see the very first one is this IP address. You can see the source is from 125. So we are not there yet. If you check the left side, when the AP replied with the second frame, it even didn't contact the router at all. It directly replied to the guest already. Think about it. The guest machine requests a internet URL. The AP even didn't bother check the internet. It directly replied. What a weird process. So let's see why it happens and what's the underlying settings. For this video, the AP is in the center. It plays the crucial role in every single step. AP's main function is not about routing. One of the AP's main functions is bridging instead of routing, and the U6 Pro is using Linux, and for Linux, EB tables is used for Ethernet bridge frame table administration. Let's check the EB tables inside the AP. The EB tables is the hero for this video. So in the lower part, I have two terminal sessions open already. I have SSH'd into the AP. In the left side, let me run the command to show the NAT table for the AP. I want to display the NAT table. There are a lot of interesting information inside the EB tables, so to help us understand it better, for each step, I break it down to more details. Let's go through the process. So the guest machine, Mac Mini, try to connect to this detection URL, right? So then the Ethernet frame reaches the AP. It will first go to the pre-routing chain. In the lower part, let's find where's the pre-routing. Scroll up, and the pre-routing during runtime, it will be executed from top to bottom. The I means interface. Just by checking the interface name, I know the ones before this particular one, they are not relevant at all because we are talking about VLAN 40, the guest VLAN. So only starting from this one, that's what we are interested. So basically what it says is if the interface is the VLAN 40's interface, it will continue. Continue means it will not leave this chain. It will continue the execution. Ignore the mark part. It's out of scope for this video. Let's continue. This interface, not relevant. This one, no. This one, no. So all the way down to the very last one. Here we are at the VLAN 40 interface again, right? See, it will jump to another chain. The name is guest in. So you can see as in the diagram, because it's VLAN 40, it will jump to another chain. So let's continue. Let's find out where is the guest in. We are here, the guest in chain. Let's read from the beginning because we know the Mac machine is trying to access this IP address, the 17 dot something, right? So apparently not the first one, not this one, and not broadcast, and not ARP, and not DNS. It's not allowed, then it's not IPv6, it's not broadcast, again not this IP address, not this IP address. Okay, here as long as it's TCP, the port is 443, it will jump to captive portal. This is not relevant to our video because we are trying to access the normal port 80, right? So continue. Whether it's guest restricted, the purpose of this rule is to drop the activity if you try to connect to the other machines within the local network. Guest network is isolated, right? But apparently our target is the internet IP address, not local network. So this rule doesn't apply to us. And next, here we are. The other host keyword means the frame is not a broadcast, not a multicast. And remember here we are trying to access a remote internet IP address, not a host within our own network, right? So our frame will meet the requirement for this condition. Then see what will happen. It will jump to authorized guests. Let's continue to see what's authorized guests. For the authorized guest chain, the condition is if the MAC address for the guest machine is in this set, it will be considered as authorized. Then what's this set? In the right side, let me show you the content of this guest authorized MAC set. The command I'm going to use is ipset. Ipset lists this guest authorized MAC. Currently, it contains nothing. There's no guest machine is authorized yet. It makes sense because this Mac machine is the very first one that tries to connect to internet. Because the MAC address is not within this set, it does not meet the requirement, so it will not accept. And then see the policy is return. Return means it will not exist the previous chain. So let's go back to the previous chain, guest in. So the return means it will return to this step and then continue. So it will not exit. Then let's continue. The next one, okay, we use TCP protocol. The port number is 80. Then we completely satisfy this condition, right? What's the jump target? It's redirect HTTP. See the diagram? Now we are here. Let's check the chain called redirect HTTP. It seems very simple chain. There's no condition at all. It will directly jump. It will continue. Continue means it will not exit. It will continue to this rule. This rule is redirect. The redirect is a keyword for EB tables because we are now checking the net table. Redirect means the redirect target will change the MAC target address to the AP's MAC address. Let me repeat. What the redirect action really does is at this step, originally the Mac machine is trying to connect to this IP address. But after the redirect, the target will be changed to the AP's bridge MAC address. So which means originally the Mac Mini wanted to connect to the Apple's domain name. But at this step, instead, the system will let the AP respond to the original request. That's what the redirect means. The redirect plays a very important role in this process. Think about it. Now the target MAC address is changed to the AP, but the port number is still 80. What will happen? The system will try to connect to this AP with port 80. So let's see what will happen exactly. In the lower part, in the SSH session, let me show you what the AP is doing for port 80. I want to see the current situation for the process and port relationship. I want to see what the redirector process is doing. See what the redirector is doing for port 80 is no matter what the IP address is, redirector will respond. See the R0 IP address, it means any IP address. This is what redirector process is doing inside the AP. It's listening at the port 80 number. And what will this process do? Just to remind you, let me show you the redirector's configuration file. Redirector process will redirect whatever request to this URL. The web page is hosted by the cloud key by network controller, and it is the captive portal or hotspot portal. In the diagram, redirector is listening on the two parts and it will redirect to this URL. This process may be very difficult to understand if it's the first time you see it, but as long as you follow the step-by-step logics, it will help you a lot to understand the following steps. It's the first time the magic happens. The Mac Mini only wanted to access the detection URL. After the step-by-step redirection, the Mac Mini will be redirected to access the hotspot portal. That answers our very first question, why the hotspot portal pop-up was displayed automatically. In this step, only the guest machine and the AP are involved. From the captured frames, you can see there's no access to the router, to internet, or even to the hotspot portal yet. The video is already more than 20 minutes, but we just started the detailed analysis. So I will continue the remaining parts in the next video. Okay, thanks for watching.